Alright, so I found this question in section 3.1 of the textbook, and I admittedly have not even tried to solve it yet. So I looked at it, it looked really interesting because it looked really different, but you know, I wanted to go through it for the first time on the video so you could sort of see my problem solving approach and how I'm actually thinking about solving these problems. So the question is, for what values of a and b is the line, this line, tangent to the parabola, this parabola, when x equals 2? Okay, so honestly, like the first thing I'm thinking about is just drawing the picture. So I mean, I have a parabola which is given to me, and you know, a is unknown, so it's, you know, going to be like either this way or this way, right? It's going to be like sort of compressed or expanded. And then when x equals 2, this has to equal some given line. So the tangent line has to be like some line like that, right? So it has to like sort of match up perfectly. So we have to find a and b that make this work. So I guess maybe my first instinct is I don't like how this is written, so I'm going to write y equals minus 2x plus b. So I have it in slope-intercept form. Oh, and actually when I do that, right, I notice that the coefficient here, right, is the slope of that line, m equals negative 2, which actually gives me some very important information, right? It's telling me that actually this picture is not correct. What I actually have must be an upside-down parabola, right? Because at x equals 2, I have something with slope negative 2. Okay, so actually this is good, right? So I have a better intuition. This should mean in particular that a is a negative number, right? If this is a downward-facing parabola. Okay, so some useful information already. So if this is the slope of the tangent line, I guess what I also need then is the slope, or the derivative of this at x equals 2 must equal the same number, negative 2. So let's go ahead and do that. Right, so y prime of the parabola, so let me write this down, this is the parabola equation. The y prime is 2a times x, it's a function of x, using just the power rule. And I care about what happens at x equals 2. So I'm going to go ahead and plug in 2. I get 4a. And from all this, I know that that slope has to match up with the tangent line slope, so that needs to be negative 2. Okay, from here. Okay, so good. We already got a equals negative 1/2. And that does confirm, right, what we thought before, which is that a should be a negative number, because it should be downward pointing. Okay. So we don't know b yet. Okay, so we don't know b. I guess, you know what we can do, right, is we can, so we now know the parabola's equation, right? Y equals negative 1/2 x squared. And I know I'm talking about the point x equals 2. So I can go ahead and probably just find the equation of the tangent line, and that will tell me what the b is, right? That'll tell me the missing b. So let's go ahead and do that. Let's just find the equation of the tangent line. So I already know the derivative, right? I already know the derivative. So y prime equals of x equals negative, well, I can use the power rule again, or I can just know that a was negative 1/2, so this is negative 1 over all x, so negative x. And at y prime of x equals 2, I get negative 2. I guess this is redundant, right? I already knew that. I guess that's extra work I didn't have to do. But that's okay. That's okay. And I need to know the x and y values. So I know the x value. I don't know the y value yet, right? So the y value is just plugging that in. Negative 1/2 times 4, which is going to give me a negative 2. Okay. So this is the point. So the point I'm talking about must be 2, negative 2. All right, so I think we have enough information now. So the tangent line must be given by y minus negative 2 equals slope, negative 2, times x minus 2. So let's see, y plus 2 equals negative 2x plus 4, and y equals negative 2x plus 4 minus 2 is plus 2. Alright, so comparing this equation that we got for the tangent line with the other original one, it becomes clear that b must have been positive 2. There you go. Alright, fun problem. Well, it's interesting. So I think you could see that I didn't do it the most efficient way, maybe, but I sort of just followed my nose and tried to do all the things that I knew how to do and connect them to concepts. So if you have any questions, let me know. Hopefully you found this problem interesting, and we'll talk about it if you have any questions.